Lastly, let's look at how we can calculate the so-called x and y-intercept. So let's write down the title in general: intercepts. Now, what are they? Intercept is basically the point at which a function, or line for that matter, crosses an axis of the coordinate system. Point at which a function crosses an axis of the coordinate system. So let's simply draw an axis and then a second axis. Of course, this axis is the x-axis and the y-axis. And let's draw a function. Let's draw a function that can look something like this. Okay? And let's say, for the sake of argument, this is minus x minus, let's go with 3, okay? There are 2 points where it crosses the axes. This one in blue and this one in green. The blue point we call the x-intercept. Sorry. Did I say intercept? Intercept. I realized I wrote it with a C, but never mind. And then we have the y-intercept. Y-intercept. So how do we calculate them? Now, the rules are fairly simple, that when we look at the x-intercept, the y value is 0. So let me draw a blue line right here, right? If you look at it, what is the y value at this point? It's y equals 0. So that's the x-intercept. How about the y? If we look at this line, going all the way down through the y-intercept, we see that this point is x equals 0. So let's calculate both of them. I would start with the y-intercept because it's oftentimes much easier. So y-intercept. The rule that we will use, which is always applicable, is that we're essentially plugging in the x value of 0. We're just plugging in 0 because we know that x equals 0. So what is the result? If we plug in 0 into our function, we get 0 minus 3. How do I know that? I just simply look at the function that we have here, and I plug in our x number. The result is minus 3. The coordinates of the intercept is 0 because of x equals 0, and then minus 3. How do we determine the blue point, the x-intercept? That we will use the fact that we have to find a value of x such that y equals 0. So let me write down my function in red, okay, minus x minus 3, and then we add an equals 0. Now, the easiest way to find x that satisfies this equation is by simply taking it and putting it on the other side of the equation. Now, let's show it in a proper fashion. So The proper fashion is that from both sides I add x. Okay, so imagine that I add x here, and I add x where, well, the 0 is. As you can see, x minus x is simply 0. So this goes away. But on the other side, the minus the x stays. So we get minus 3 equals x, and this is our result. The coordinates of the x-intercept is now minus 3, 0. A common misconception is that when we want the x-intercept, x equals 0, and that's not the case. It's always reversed. Let's do one more quick problem where, however, we have 2x plus, let's go with plus 3. So to find the y-intercept, I'll use green. Y-intercept, I'll just write it like this. We need to plug in 0, so I plug in 0 into x. So 2 times 0 plus 3 equals 3, and the coordinates are very straightforward since x is 0, is 0, 3. However, how do we do it with the x-intercept? How do we calculate the x-intercept? We write down our function and we equate it to 0. Now we need two things. First, I will put this plus 3 on the other side of the equation. A fast way to do it is that when we have plus here, on the other side is minus. So we get 2x minus 3 equals minus 3. And now what do? We divide by 2 from both sides. So divide by 2 here and divide by 2 here. The 2's cancels out, and the result is that we have minus 3 halves. That is a result. And then the coordinate system, or sorry, the coordinates of the x-intercept is as so.